Dear student, today we are going to learn chapter number 4, that is practical geometry. Before we go through this chapter, we should recall few points that we have learned earlier. Dear student, we have already learned about the basic constructions like the constructing line segment, angles, perpendicular bisectors, and about the construction of the triangles also in our previous class. Today, we are going to learn about the measurement for the construction of quadrilaterals. In these chapters, in the practical geometry, we will learn about how to construct a quadrilaterals. Let's see to the today's topics. A quadrilateral has 8 elements. It means there is 4 sides, 4 angles. 8 element means 4 sides and 4 angles. Moreover, it has 2 diagonals also, which play a major role in determining the size and the shape of the quadrilateral. See, quadrilateral has 8 elements. We all know this: 4 sides, 4 angles. Beside that, it has 2 diagonals also. These 2 diagonals which play a major role in determining the size and shape of the quadrilateral. So, in all, we have 10 elements or a measurement. Means including the diagonals, there are 10 elements for quadrilaterals. That is 4 sides, 4 angles, and 2 diagonals. We need to know the 5 measurement in order to construct a unique quadrilateral. Yes, we have 5 elements, but we have 10 elements, but we have to know the 5 measurements in order to construct unique quadrilateral. To construct the unique quadrilateral, we have to know the 5 measurements. With the help of following measurement, we can construct quadrilaterals which are unique. These are the 5 measurement points that can be construct a quadrilateral in a unique form. The first one is 4 sides and a diagonal. By constructing 4 sides and 1 diagonal. The second one is 3 sides and the 2 diagonal. That is, 3 sides are known and the 2 diagonals are known. It means that given, okay, 4 sides and 1 angle. 4 sides given and 1 angle given. We have to construct the quadrilateral. Number 4, 4 sides and 2 include angle. In the given question, there will be 3 sides and the 2 angles. And the fifth point is 2 adjacent sides and 3 angles. 2 adjacent sides and 3 angles. There are 5 elements which make the quadrilaterals in the unique form. These are the 5 points that we have to be remembered. 5 measurement that makes a construction of quadrilateral to be unique. Okay, the first one is 4 sides and a diagonal, 3 sides and 2 diagonal, 2 sides and 1 angle, 3 sides and 2 angles, 2 adjacent sides and 3 angles. And other special properties, example in case of squares and or a rhombus. Means you want to construct square and rhombus, according to the special properties we can construct. But moreover, the 5 things is very important. The 5 measurement is very important to construct the quadrilaterals. So here we will start the construction one by one. Okay, let's see the points. This is a question given 4 sides and a 1 diagonal. Here, construct a quadrilateral skip in which SK is 5.5 centimeter, KI is 5 centimeter, IP is 6 centimeter, PS is 4 centimeter, and diagonal SI is 8 centimeter. See, they are given 1, 2, 3, 4. We have 4 sides and 1 diagonal. First we have to draw one rough diagram. Okay, let's see. Here comes, we'll draw diagonal first. Diagonal is SI. SI is I centimeter. And now comes P. Here comes K. Now PS is how much? 4. And this PI is 6. And SK is 5.5. KI is 5 centimeter. Now in this form, we have to draw one we have to construct a quadrilaterals. So construction before we construct any quadrilateral, we first draw a rough sketch for the figure to construct, so that it make easy for the construction also. So first thing what we have to do, let's start first. The first point we draw, I will draw in a freehand. Okay, first point, we draw a line segment that is 8 centimeter. We point it as a S and a I. This is the first step. The second, S is the center, and the radius of 4 centimeter. We draw an arc here. From S is the center, we draw one arc here. Okay, and again taking I as centers with a radius of 6 centimeter, we draw another arc that intersect the second step at point P. So that, and then again taking S as a center, a radius of 5.5, we draw another arc below the SI. So here is, we draw another arc here. Again, with I as a center at radius of 5 centimeter, we draw an arc intersecting the arc in step 4 at point K. There is a K. So join PS. Now we have to join PS and the IP. And again SK and the SK. Now we have joined PS, IP, SK and the IK. Now the measurement, this side is 6 centimeter, this side is 4 centimeter, this side is 5.5 centimeter, and this side is 5 centimeter. The step, for the construction of the step, first we draw a line segment that is 8 centimeter, that is SI as a diagonal. We draw this first, and then with AS as a center, we draw an arc with the radius 4 centimeter. We draw an arc above the SI line. Okay, and then with I as a center, again we draw another arc which intersect. We draw with I as a centers with the radius of 6 centimeter. We draw another arc above the SI which intersect the previous I at the point P. And again with the center IS, we draw another, with the radius of 5.5, we draw another arc below the line segment SI here. And again with I as a center, we draw with the radius 5 centimeter, we draw another arc below the SI which intersect the previous arc at the point K. Now join SP, PI, IK and the SK, and this is a, hence skip SKIP is a required quadrilateral. So in this way we can construct by given four side and a one diagonal. Okay, this is a first example for given 4 side and a one diagonal. Next we will see another example. Here is a second point, given 3 side and 2 diagonal. Construct a quadrilateral RAN in which RA 6 centimeter, RN 5 centimeter, IN 7 centimeter, and diagonal RI 7 centimeter, AN 7.5 centimeter. Here one side is missing, but we will conclude the one side. Okay, first let's draw one rough diagram. First we draw the line segment here. Line segment that is RL, RI, that is 7 centimeter. Diagonal RI will draw first, and then here with RI centers we'll draw here N RN 5 centimeter, and the RI is 7 centimeter. This arc, okay, 7 centimeter. And again in the below this RI, we draw a line segment that is A. Okay, here comes A, and from here we will take one arc and we will join here, and we can join this diagonal again here. This will be 7 centimeter, this will be AN will be 5.7. This will be A, and this RA will be 6 centimeter. So that we can join this IA very easily. Okay, if we have draw three side, then it's very easy to conclude the last one. Okay, so now let's start drawing here again. This is a rough sketch. Before construction of any figures, first we need to draw the rough sketch so that it makes easier for us also to draw any construction. So in the first step, here also we have draw one line segment, that is RI. RI is equal to how much? 7 centimeter. That is RI is a diagonal. We have drawn this first diagonal, and then in the second step, with R is the center, we draw RN. That is 5. R is the center. We draw an arc here with the radius of 5 centimeter. We draw one arc here, and again I is the centers. I is the centers. We draw 7 centimeter with the radius of 7 centimeter, and cut the previous arc at the point N. Okay, yes, we cut N. This is N. This is the radius of RI. RN is in the 7 centimeter. Okay, now we can join RN and the RI. So we can join here these two. We have joined these two. Okay, this one is RN is equal to 5 centimeter and RI is 7 centimeter. We have drawn this 1, 2, 3. Now remaining is RA and the diagonal AN. Now see again RN. RN means another, again taking R as center, again with the radius of 6 centimeter, we draw an arc below the RL. We have drawn here one arc. The center 6 centimeter. Okay, then with N as a center, N as a center, with N here, with N as a center with the radius of 7.5, we draw an arc intersecting the arc in step 4. In step 4, that is at the point A. From N, we draw one arc here. Okay, then we join RA. This is, we call it A. Sorry, this will be straight line, and this will be I, and this will be the diagonal. This is what? 7.5. This is 6 centimeter. This is a required quadrilateral rain. Okay, rain is a required quadrilateral now. So let's start review again the step of construction. First, we have to draw the diagonal RI 7 centimeter, and after that R is at center with the radius of 5 centimeter. We draw an arc above the RL. We draw one arc, and again I is a center with the radius 7 centimeter. We draw another arc intersecting the arc in the step 2, that is here at the point N. Okay, and join RN and the RI. And the next step, the fourth step, taking R as the center and with the radius of 6 centimeter, we draw an arc below the line segment RI. Okay, and then again with the center N and the radius of 5.5, we draw an arc intersecting the arc in the step 4 at the point I here. Okay, from here. So then, and after that, we can join RA, NA, and the IA. Then we form a full unique quadrilateral. That is, so hence RAN is a required quadrilateral. This is example for when the 3 side and the 2 diagonal are given. Okay, then next we will have another example. Now this is a third example, given it 4 side and 1 angle. Construct a quadrilateral mile in which MI is equal to 3 centimeter, IL is equal to 3.3 centimeter, LE is equal to 2.9 centimeter, EM is equal to 3.5 centimeter and measure of angle M is equal to 70 degree. Now let's first draw one rough diagram here. Okay, now first we have to draw MI. Measure of MI is 3 centimeter, and then from point M we draw an angle 7 by using the protector. We draw an angle here. Okay, angle that is 70 degree, and with the center M, with a radius of 3.5, we draw an arc in this ray. So we cut here, that is 3.5. We call it here E. Okay, and then again, now the next one is we draw from the E as a center and the radius of 2.8. We draw another arc on the right side of ME here. Okay, here we draw one arc. Here we draw one arc with the radius of 2.8. 2.8 means here with the radius of 2.8. Okay, and then again from taking I as a center with the radius of 3.3, we draw an arc intersecting the arc in the step 4 at the point from here. One arc we have to draw, and then the meeting point of these two arcs we call it L. Join IL. We can join this IL and again LE. This is a required quadrilateral. Very simple. Okay, now we'll draw here again. First, the step of construction. This is a rough sketch. Okay, now the step of construction. In the step of construction, first draw a line segment MI equal to 3 centimeter. Now we'll draw one line segment here, that is MI, that is 3 centimeter. In the second step, at the point M here, on a line AI, we draw angle IMX is equal to 70 degree. With the help of protector, we draw one angle that is 70 degree. This we call it the ray X. Okay, and again taking M as a center with a radius of 3.5, we cut an arc on the ray MX intersect at the point E here. We point it here. This is a 3.5 centimeter. Okay, and there again from point E is center with a radius of 2.8, that is this one 2.8, and we draw an arc to the right side of the ME, this side. Okay, from this side, right side means put one arc here. And the last one, taking I as a center at a radius of 3.3, we draw an arc intersecting the arc in the step 4 at the point L. Here we draw one arc with 3.3 radius. This is, we call it L. Now we can join LI and the LE. This is a required mile, hence MILE is a required quadrilateral. In this way we can construct a quadrilateral by using 4 side and 1 angles. Next, we'll see another next examples. This is number 4. Given 3 side and 2 include angle. Construct a quadrilateral ROM in which RO 4 cm, OM 6 cm, ME 5 cm, angle O is equal to 100 degree and angle M is equal to IT degree. Now we have to construct this. So first of all, we have to draw one rough sketch. So for this, we have to draw one line segment here, that is OM, that is 6 centimeter. And from the angle O, from center O, we draw a angle. We construct an angle by using the protectors. We draw a ray. This is x. This is what? 100 degree. From O we construct one ray that is measure of angle MO. X is equal to 100 degree. By using protector we can draw one angle here, and again from the center M, point M, on OM, again we make another angle OMY as a 80 degree. Now again we draw one ray here. Here one ray, that is we call it Y. Here comes 80 degree. Okay, then from the M we can draw we can draw an arc of from M we draw an arc with the M at the center. We draw a radius of how much? 5 centimeter. We draw here, and that joining point we call it E. Okay, from O also we draw an arc at 4 centimeter. We name point has R. Join R and E, we form a quadrilateral ring. Okay, so here the step of construction. First, before we construct, we have to draw one rough diagram. Okay, so here first of all we have to draw a line segment that is OM, that is 6 centimeter. This will 6 centimeter, and from OS centers at the point O on the line OM, we make an angle MOX. That is MOX how much? 100 degree. And again at the point M on the line OM, we draw another angle that is OMY. That is 80 degree. Okay. Then taking O as the center with a radius of 4 centimeter, we draw an arc at the ray OX here and intersect the OX at the point R. Here is 4 centimeter. And here again from the point M as a center with a radius of 5 centimeter, that is this one 5 centimeter, we draw an arc on a ray MY that intersect at the point E here. This is 5 centimeter, and then we join ER. So we form a quadrilateral rho. This is a required quadrilateral by giving 3 sides and the 2 include angles. Okay, here this is the last point, given 2 adjacent side and 3 angles. Here we have to draw first a rough diagram for the given points. Okay, first PQ is how much? 6.8, and there again from P angle 110, and again from Q we draw an angle 70. Okay, then again here we draw R. This is R. This will be 7 centimeter, and we have to join this. We call it S. This is a required diagram we have to be construct. Okay, because 2 adjacent side is here, and here this will be 130 degree. 2 adjacent side is here, 3 angle is here. We have to construct this quadrilateral. Okay, see, first step, draw a line segment of PQ. First we need to draw one line segment, that is PQ. We draw a line segment PQ with a PQ is equal to 6.8 centimeters. Now at P, from here we construct QPX of measure of 110 degree. So we have to construct one angle here, that is 110. This one is X. PX is a ray. Okay, and again with Q at the point Q, again we need to draw one angle, that is angle 70 degree. Okay, by using the protector we can use the angle we can draw the angle PQY. We draw one. We need to draw one angle here again. That is 70 degree. Okay, and then after drawing this, we have constructed a line segment PQ, angle P, angle Q. And the fourth step is from the center Q and the radius of 7 cm, we draw an arc intersect at the point Q. From here, we draw an arc in this ray here at the point R. We call it R. This is 7 cm. Okay. Next, again, from the we at R construct an angle QRZ 130 degree. From the center, from R as a point, we need to construct one angle that is 130 angle. So with the help of protector R as a center, we draw an angle here. There is a center. Okay, this center is, we call it 130 degree. So this is a ray Z, the joining point from here to here. Now again, the point intersect at the point where PX, right? Here we intersect PX, and the RZ is at the point where S. Means this two ray, that is PX and the RZ, is intersecting at the point S. This is the fourth vertex of the quadrilateral. Because the two adjacent side 1, 2 is given, now we have drawn this side, and this side also. So quadrilateral PQRS is a required quadrilateral. Understand? PQRS is a required quadrilateral. See, let's see. I will repeat again. First, we need to draw a line segment of PQ, and from P, with the help of protector, we draw an angle 110, and from Q again we draw an angle 70 degree. From Q as a center with the radius of 7 cm, we draw an arc which intersect Q and Y at the point R here. And again at R, from R we construct an angle QRZ, that is 130 degree. Here we have to put a protector, and we have to measure 130 degree, and we have to construct an angle QRZ 130 degree. And then the point of intersection of PX and the RX, we call it S. This S is the fourth vertex of the quadrilateral. So we form an shapes of the quadrilaterals, right? By using two adjacent side and the three angles, we construct a unique quadrilateral, that is PQRS. These are the 5 mantras, or any mantras, we can say mantras also, okay, to construct a quadrilateral which are in form of unique. Okay, these are the 5 measurements. 4 side and diagonal, 3 side and 2 diagonal, 4 side and angle, 3 side and 2 include angle, 2 adjacent side and the 3 angles. These are the 5 measurements that we need to construct. In order to construct a unique quadrilateral, we need 5 measurement, is 1, 2, 3, 4, 5. Okay, now the last one. Construction of few special quadrilaterals are there that we can construct. When a special quadrilateral are to be constructed, not all 5 elements need to be specified, as there are many hidden relationships between the elements. If a square is to be constructed, means without any these 5 elements also we can draw. If a square is to be constructed, we all need to know its length of its side, 4 cm or 6 cm extra. This is given as the length of 4 sides, and we already know that the 4 angles are 90 degrees. 90 degrees. And many such special quadrature can be constructed by keeping in mind properties of their side angles and diagonal. It means that beside these five elements measurements of quadrilaterals, the construction of special quadrilateral means like there are few shapes, few figures that we can draw by using their properties. See, in case of the square, if we know all the side and all the degrees, then we can construct very easily. Or in such many cases, we can construct the property by using the properties of the uh, particular figures like square, rectangle, rhombus, trapezium, kite. You want to construct these things, then we have to follow their properties. So let's discuss one example. Example for construction of special quadrilateral. Let's see some special quadrilateral. We have pick up one shape for we have pick up one shape that is square. Okay. See, the name of that square is cube, in which CU is 6.4 centimeter. We all understand that for a square, all the sides are equal, all the four sides are equal length, and all the angles, interior angle of the squares are 90 degree. We all understand. Then we will draw one square here. All the side is 6.4, 6.4, 6.4, 6.4. All the angle inside the square is interior angle is 90 degree. CU, then B is EB. We need to construct this square. So first we need to know is that in a square all the sides are equal length and all angle are equal to 90 degree. We have to understand this first. So first of all, we have to draw one line segment, that is CU 6.4 centimeter. We draw one line segment that is CU 6.4 centimeter at the point C. From here, C and U, on the line CU, we draw an angles UCX, that is UCX, an angle CUY. It's equal to 90 degree. So we need to draw here 190 degree, here 190 degree by using protractor or by using compass. That is upon the that is depend upon you. Okay, we draw 190 degree here, here also 190 degree. You can use compass or you can use the protectors. This is a ray. This ray we call it, we keep here Y. This is X. Here we have drawn 90 degree, 90 degree. It's 90 degree, 90 degree. Okay. Then again, taking U as a centers with a radius of 6.4, again with the U as a center, we draw an arc with the radius 6. We draw an arc on the line UY, intersecting it at a B. Yeah, B. It is 6.4 again. Okay, and again this C as a center, again with the same process, we will draw 6.4 centimeter and draw an arc on line CX and intersect at the point E here. This is E, 6.4 centimeter. And then join BE. Now we have to join BE. BE. And this BE, we join the BE, then hence CUB is a required square, because if there is two right angle and all the sides are equal, then this two angle, that is angle B and angle E, is also absolutely 90 degree. Okay, if we are not constructing these two also, we can easily say that both angle will be surely 90 degree, because we have constructed 290 degrees and three side are equal. So definitely these two angles and this side also will be definitely will same, will equal. So we no need to again measure the 90 degree here, because here we have already measured two sides are equal, three sides are equal. Then definitely these two angles also will be equal, and this side also will equal, because according to the properties of the square. This is for the special quadrilateral. Okay, we can draw the square we have done. The second one is rectangles. In case of rectangles, all the angles are 90 degree, and the opposite side should be equals. Opposite sides should be equal. In case of rectangles, all the angles should be 90. Interior angles of all the rectangles should be 90 degree, and the opposite side are equal. Pair of their opposite side should be equal. In this way, we can draw again this one, kite. Kite also we can draw the kite by using their properties. Diagonal and right angle, it should be right angle. One of diagonal bisect the others, and the pair of consecutive side are equal. This is a rules for diagonal again. So by using each and every properties of trapezium, kite, rectangles, rhombus, square, we can construct as a special quadrilaterals. So dear student, this is a last part, that is for this chapter number 4, that is some special quadrilaterals. So we will, before we wind up, we will recall few points that we have learned. See children, we have 5 elements to measure the in order to construct a unique quadrilateral. We have 5 measurement. Okay, the first one is 4 side and the diagonal. Second one is 3 side and 2 diagonal. Third one is 4 side and the 1 angles. Fourth one is 3 side and 2 include angles. Fifth is 2 adjacent angle and 3 angles. And again, we can construct, these are the 4 elements that we can construct a unique quadrilaterals. And again, there are a few special quadrilaterals. They are kite, trapezium, square, rhombus, and rectangle. Okay, in this case, we no need to be to construct not all the 5 elements need to be specified, because we don't need any these 5 specified elements, because here in this construction of special quadrilateral, they have a features particulars properties for its figures. Okay, like if we discuss about square, we know that all the square has 4 sides are equals, and the 4 angles are 90 degree. We have already learned. So according to that, for the special construction for a special quadrilateral is we need to focus mainly on their properties. Okay, so many such special quadrilaterals can be constructed by keeping in mind the properties, side lengths, and the diagonal. Okay, this is about the construction of a special quadrilateral, and this is about the construction of the unique quadrilaterals. So this is and we have drawn few examples and all. So student, this is a last part for this particle geometry, and so student, please look the please practice at home again to know more knowledge about the constructions of quadrilaterals. So student, let's wind up here for these topics. So thank you.